Hello class, Professor Anderson here. Let's take a look at an example of calculating the motion of a boat on a river. It's going to go downstream and then it's going to go back upstream. And we're going to know some things. We're going to know how long it takes to go downstream. We're going to know how long it takes to go back upstream. And we're going to know the distance that it went downstream. And what we have to figure out is how fast is the river moving. Okay? So let's see if we can draw the picture out to start with. Okay, here's our river. Here's our boat. And it's going downstream. We have some velocity of the river relative to the earth. We have some speed of the boat relative to the river. And when we add those up, we're going to get the speed of the boat relative to the earth. And what they tell us is that this distance, d, is 25 kilometers. And the time it takes the boat to cover that is 3 hours. We'll call that T1 going down the river. All right. Let's just think about that problem for a second, right? If the boat is moving in this direction and the river is moving in the same direction, then there is a speed of the boat relative to the earth, which is clearly just the sum of those. V of the boat relative to the river plus V of the river relative to the earth. But we also know what that speed is because they give us the distance that it went and they give us the time, T1. Okay, so that's how fast it will move down the river, d over T1, relative to the earth. Now, what about the second part? It says it's going to travel the same speed back up the river relative to the river, but it's going to take 6 hours to go back up. All right, so let's draw the second case. In the second case, the boat is going to turn around. It's going to go up the river. It is still traveling at V of the boat relative to the river. The river is, of course, going to the right still. And it's going to cover the same distance d, but now it's going to take twice as long, 6 hours. So what is the speed of the boat relative to the earth in this case? Well, it is v of the river relative to the earth minus v of the boat relative to the river. Okay, you can make it positive or negative. But since we're saying stuff to the right is positive, then we'll just keep that nomenclature. VRE is to the right, so that's positive. VBR is to the left, so that's negative. And now we're covering a distance d, but we're going back this way, so let's put a negative right there. And how long does it take? Negative d over T2. And now look what we have. We have that equation, we have that equation, and we have some unknowns. What are the unknowns? Well, we don't know v of the boat relative to the river. We don't know v of the river relative to the earth. We do know t, and we do know T1, d and T1. And same over here, right? Don't know that, but we do know that, and we do know that. Two equations, two unknowns. We should be able to solve it for what we want, which is the river relative to the earth. We're looking for VRE. All right, let's do it. Okay, these are the two equations that we ended up with. We are looking for VRE. So let's just take this equation and rewrite it. And let's substitute in VBR from the second equation. Okay?